Hi everyone, in this video we will discuss about how you can plot band diagrams using Python. So this is one of my publication that we worked on nanostructures, and this is the paper. And if I scroll down, you can see that we have nice band diagrams. In fact, this is actually drawn in Python. So I've modeled and we have calculated the DFT calculation of the electronic band structure, and we have plotted it using Python. So let's see how we can plot this graph in Python. So I'll just open the VS Code, and as you'll be able to see that just writing few codes, you can easily create stunning plots in Python. You don't have to use any complicated software to do that. So the first step is to import the matplotlib package. So I'll write import matplotlib dot pyplot as plt. Okay, and then we'll import numpy as np. So these are the two import statements that are actually required by basically any kind of plot that you do in Python. Now the next part is to read the data. So you'll write data equal to np dot genform text. Actually this is txt, and we'll open and close brackets, and here we'll write the file name. So my file name is 2.43 ev.csv. okay, then we'll have comma, then we need to write delimiter equal to, in quotation, as empty, and then we'll have names equal to, and in the third bracket we'll have x and y. So this is basically reading the file separated by comma and the two columns, since in CSV file generally the data is separated by comma. And then we'll just write plt dot axis, and we'll write the x range, that is 0, 1, and then the y range, that is -10, 25. And then we will write plt dot plot data, and in third bracket we will write x. So I'll just use the first bracket and then again comma. Just to make this faster, you can just copy this, and this will be y, comma, label equal to raw data. Okay, so we have the plot almost ready, and now what we will do, we will just write plt dot title, and we can just write band structure, and we can write plt dot show. So now if I run the file, you can see that I have this band diagram of the CSV data. Now if I open the manuscript, you can see that this is exactly the same graph that is there in this paper. So this is the same graph, as you can see. Now I'll minimize this. Now what we can do, we can add the letters and the dotted line also. To do that, we'll go on to the code and update few lines. Let us first write the x positions. So I have x underscore positions equal to, we need to write the positions as an array. So at first it is 0, then let's say we want to write a letter at 0.6 and then again comma, and I have 0.8 and at last it is 1. So if you open the diagram, you can see that the plot is from 0 to 1. So we are dividing it into different sections according to the lattice structure. So I have the x position. Now the next part is to write the labels. So we'll write x labels equal to, and correspondingly we need to write the label. So this is k, comma. So we have the symbol gamma. I will just copy this from the web and I will just paste it. Then we have m and then we have k. Okay, so the x level is done. So now what we have to do is we need to write plt dot x ticks, and we need to write the x positions and the x levels. So we'll write x position comma x levels. Okay, so we are almost done. Now what we can do, we can just run and check. So as you can see that we now have the symbols at different positions in the graph. Now let us draw the vertical lines that are essential to describe some phenomena within the crystal lattice. I'll just close this, go back to the code, and I will just write a loop so that it will just scan through all the point and create a vertical line. To do that, we'll write for POS in x positions. Okay, POS is just a variable. You can write whatever you want. You can write plt exv line, first bracket, then x equal to POS, comma, color. We'll define the color. Generally for plots we draw a gray line, comma, line style equal to dotted, line width equal to 1. Okay, and the loop is almost done. Probably we are not having any error, so let's run the code and see if it is working. So you can see that I have the plot now, and all the different planes, the dotted line and the title and the graph, everything is almost done. And you can just put the x-axis and y-axis names and you're good to go. You can just click on save as figure, or you can just take a screenshot, whatever is convenient. And one more thing that you can do in Python that I don't think any other software do it as well is that you can drag your mouse and make whatever ratio you want. Generally for density of state or Venn diagram, people tend to plot in a portrait mode just to make the curve more prominent. So you can do that, or you can just make it in a form of square, or you can just save it in the default shape. And also, since this is a Python code, you can play around with different settings, add grids and so on. So this is how you plot this kind of professional graph in Python. I hope this tutorial helps, and you can see that the code is quite small. So even if you are a beginner in Python, you can just use this code and play with it. You just need to have a CSV data with X and Y columns. I'll just show you the data once so that you don't have any confusion. So this is my data. Just forgot the D and E columns. I'll just scroll and show you that this is the data, and these are the two columns that we are actually plotting. Okay, so I'll just close this. So this is how you actually plot band diagrams in Python. So thanks for watching. If you learned something, do subscribe this channel and support. By the way, I will share the Python script and a sample band diagram CSV file so that you can play around, and it will be for the members, so they can just download the PY file and use it for the publication work. You don't have to cite me or anything, and otherwise you can just follow the tutorial and just write this line of code and follow. Thanks for watching and have a nice day ahead.